Hello M3, this is Teacher Win and this is our last unit for term 1, which is chemical reactions. So for this lesson, I'm going to divide this into 4 parts. So this video is part 1 of your chemical reactions. To begin our lesson with, let's start first with the elements. So what is an element? So an element is a substance that cannot be broken down into smaller or simpler substances. So like for example, so you have here an object which is round. So you're going to divide it and you will get this part, this size, right? And then you're going to divide it and this part until you will get only the smaller pieces until to such point that you cannot divide it anymore. So this example here is like my element. So it's like it's the smallest unit of any object or of any particles that exist in this universe. That is your element. So what are some examples of these elements? So that includes your copper. So we have your iron, your aluminum, your oxygen, and also your carbon. So speaking of your elements, so each element is given a symbol because the name of the same element is different in universal languages, but the symbol is universal. So let's try to look at the example element, which is an iron. So iron in Thai you would say leg. In Latin you will say ferrum. And in English it says iron, right? So different countries, they have different version of the so-called iron, right? But one thing is common is that anywhere you go, as long as you can see Fe, then that Fe here means ferrum or iron or lead. This is what you mean by the symbols of element having only one symbol in different languages. So speaking of your elements, so they can be found in your so-called periodic table of elements. So in this example, so there are 118, by which 92 of this 118 is natural. And the rest, elements 93 until 118, they are man-made. So elements are arranged in this way according to its property, to its boiling point, to the number of electrons, to the number of protons, or overall, the overall properties of your element. So we will be learning this element as we go on with our lesson about chemical reaction. So what is a periodic table? So it is like a simple table wherein it organizes your elements in a particular way. So speaking of your particular way, so your periodic table is classified according to metal, metalloids, or your non-metal. So let me just shade this part. So this boron, silicon, germanium, arsenic, antimony, tellurium, and your polonium, this is like the separator of your periodic table. So meaning, if you go to this side, okay, this is more of your metals. If you go towards this side, this is more of your non-metals. And the one that is shaded, they are your so-called your metalloids. So this is the first way on how scientists separate elements. So they separate it according to metallic property, metalloids, and your non-metal. So using your periodic table, so let's try to name each element and classify them. So you can pause this video to think of the answers. Once you're done, you can play it again. Okay, let's start. So letter C, what element is letter C? If you look at your periodic table, so that's a carbon. So carbon is an example of your non-metal. Next, number 2, we have Cl. Cl or your chlorine is an example of your non-metal. Very good. So both carbon and your chlorine, so if the element goes to your right side that separates your metal and non-metal, then that is your non-metal elements. You have your Cu, which is your copper. So copper is an example of your metal. Next, we have your Fe. Fe or your iron. That's an example of your metal. Very good. Next, we have your Na or your sodium, which is an example of your metal. Very good. Au or gold is an example of your metal. Very good. Okay, so from our previous slide, so we learned about the metals and non-metals. So where are those metals? So you have here your Cl. You have here your carbon. We also have here your copper, your iron, your sodium, and also your gold. So again, so this was the boundary, right? So any metal that goes to the right, so that means this is your non-metal, right? And then the side that goes to the left of this border line, that is part of your metals. So that's why your sodium, your iron, copper, and gold are metals. Your carbon and your chlorine are your non-metals. Next, as we look at your periodic table, you might observe that your periodic table has these numbers here. We also have here like the letters or even the words and some of the numbers here that are in decimal places. So in the next slide, so we are going to name the parts of your periodic table. So this is the bigger version of these small squares that can be found in your periodic table. So let's take our example, helium, with an element symbol He. So what are the parts of your, or what's in the square? So we have here your atomic number. So this one is your atomic number. This is your symbol, your element name, and then your atomic mass. So we will be going on in each slide about this topic. The first one is your atomic number. Atomic number. So these are elements in which they organize themselves according to the number that they have. So that number refers to your so-called protons. Protons. So in our example here, which is 1, and the element name is hydrogen, so it means that this hydrogen atom has a proton number 1, meaning it has only one proton. So just in case that you forgot already about what are protons, so speaking of your atom, which is the smallest unit of any particle, so it has three components. The first one is electron, wherein your electron has a charge of negative. Next is we have here this red circle. This is what you call your proton, which has a positive charge. And then we also have here the green circle, which does not have a charge, meaning it is not positive, it is not negative. Then we call it as neutron. Neutron, or shall we say neutral. So again, in your atomic number, so you are talking about the number of protons that you have in your atom or your element. So like for example, in this picture, so we can see that this element has 3 electrons. We can also see 3 protons and also 4 neutrons here. So if we talk about atomic number, then we are looking at the number of protons that is located at the center of that atom. Next is we have the word symbol. So your symbol is just like letter that represents your element. So for our example here, hydrogen, so it can be written as capital letter H. However, if you look at element number 2, which is your helium, so how do you think should I write the symbol for helium. So I cannot write H only because H means hydrogen. So I have to use the second letter of helium, which is letter E. So this means that He is a unique symbol of your helium. If you only have only H, then that is hydrogen. The next word is we have your atomic mass, or also known as your atomic weight. Atomic weight or atomic mass. So it refers to the weight of the atom. So meaning how heavy is this atom. So our example here is we have your oxygen. So if you look at your atomic mass or atomic weight, so it's 15.999, or we can say round it off so into 16. So to get your atomic mass, so it's a combination of your proton and your neutron. So meaning in your atomic mass, that is proton plus neutron. And you have your atomic mass unit or atomic mass. So like for example, with your oxygen here, so that means oxygen has 8 protons and it also has 8 neutron, and that's why you can get here the value of 15.999 or 16. And finally, we have your element name, which is simply like the name of that letter. So what does that letter represent? So like for example, if you can see letter H, then that is hydrogen. Okay, so if you can see like letter C, then that is more of your carbon. If you can see the element symbol Ne, then that is more of your neon. Now for scientists, they write this element that represents your mass number and atomic number at the same time. So they use this AXZ. So wherein your A here represents your mass number, your X here represents your element, and your Z here represents your atomic number or your atomic weight. So like for example, so we have here the element sodium. So this is an element sodium. So your element sodium tells us that the element symbol is Na. It has a mass number of 23 and it has an atomic number of 11. So this is what you call your nuclear notation. Okay, let's go to our example. So we have here the element symbol Cl with numbers 35 and 17. So using your periodic table, so let's try to find this element symbol Cl. So here is my guide. I want you to look at this atomic number, which is 17. So in your periodic table, so if this is your element symbol Cl, then on top of that is you have your atomic number. Okay, so did you find it? Okay, that's great. So what is element symbol Cl? So element symbol Cl is chlorine. And how about its atomic number? So it is 17. So remember in your nuclear notation, this one is represented as your Z. How about your mass number? Or represented as your letter A. So it is the mass number of 35 here. Okay, now let's go to the number of protons, electrons, and neutrons. So again, what did I tell you about your atomic number? So your atomic number will tell you the number of protons. So my atomic number is 17, then therefore my atomic number of protons here is also 17. Speaking of your electrons are very tiny compared to your protons. So if this is like your proton, then your electron looks like this only. A very small dot compared to your proton. So that's why scientists assume that whatever number of protons you have, you always have the same number of electrons. So meaning, if I have 17 protons here, then I will also have 17 electrons. Okay? And finally, we have your neutron. So how do we get the neutron number here? So remember that your mass number, right? Your mass number tells you about your number of protons and neutron, right? So to get your neutron, all you have to do is to subtract, meaning neutrons is equals to mass number minus protons. So meaning neutrons mass number is, or shall we say the mass number of your chlorine is 35, and chlorine has 17 protons. So 35 minus 17, and you will get 18. So the number of neutrons that we have here is 18. Okay, so let's try more examples. So I have here 1 and 2. So using your periodic tables, I want you to complete this table ZAPEN, Z-A-P-E-N, or atomic number, mass number, proton, electron, and neutron. You can pause the video to try to answer it yourself. Once you're ready, you can start the play button again. Okay, let's try to check your answers. So let's begin first with number 1. So you have their element name, which is oxygen. Very good. And what is the atomic number of your oxygen? So oxygen has 8. And mass number? 17. Very good. How about proton? How many protons does your oxygen have? So again, you're always to look at the atomic number, which is your 8. So if I have 8 proton, then I also have 8 electrons. How about the neutron? So again, neutron is mass number, or A, minus number of proton, and then you will get your neutron. So meaning if I have 17 here minus 8 protons, then I get 9. So my answer here is 9. Now, let's go with number 2. What is the element name of the symbol K? K is potassium. Very good. Potassium has an atomic number of 19. And what is its mass number? Mass number is 39. How about number of protons? So I will look at the atomic number and it tells me it's 19. How about electron? It has the same number of your proton, which is 19. How about your neutron? So again, neutron is mass number minus proton. So that means 39 minus 19, and you will have 20. So to check your understanding M3, so I want you to click the Google Form link on your Line account. So in your worksheet, so you can find there 2 activities. The first one is you have to identify if it is metal, non-metal, or metalloids. And number 2, you're going to complete the ZAPEN table. So that ends our lesson for this video, M3. So once again, thank you very much for watching and have a nice day. Thank you and stay safe.